Welcome back. Now let me walk you through how to use Revopoint, the software, to post-process your scans. Well, first of all, let's scan this. And as you remember, Travis talked about in the previous video, Mini 2's blue light is super sensitive to the lighting condition. Now it's too strong, so let's turn this light off. Boom, suddenly improving, right? And let me put something unnecessary as noise surrounding this Medusa. Okay, looking good. Let's go. Let's just do about one rotation and that'll be fine. Okay, almost there. Let me turn the light on again. And as you can see, this point cloud, well, I won't say it's a perfect scan because what I should do is I should put this down and scan the top and the bottom of it, but let's not do that. That's because I want to show you something. So after you complete a scan, you click this complete, it'll take you to the editing processes. Now first is this. It's called one-click edit. This is quite a no-brainer. If you are new to this software and the scanner, you can, like during your first and second scan, it's better, I would recommend you to use this no-brainer. Just click that and the software will do all the steps for you. You don't have to even think. But everything comes with a price. This one-click edit does not always deliver you the best result, especially if you want some super detail and super accuracy. And in that case, you might need this. This is manual processing, right after the one-click editing. Now, first step is Fusion. Now, Fusion is the process the software will align all of the point clouds. And what is point cloud? Look, if I zoom this up, as you can see, this actually consists by tons of points. That's why it's called point cloud. It's a cluster. And Fusion is to align this cluster, make them more even and more tidy up. So now let's see Fusion. And here, point distance. As you can see, you can put this bar very big or very small. And the smaller this number is, it means the less point distance in between each of the 2 points that end up with better detail, better accuracy, and also better quality. But in return, this will end up in a longer processing time and a bigger file size. So if you're scanning something very big, well, maybe not with Mini, with the range series, and you don't want to put this point distance too low, and especially when you don't have a super high performance PC. Okay, none of that. And let's see, there are 2 fusing methods you can choose. The standard is just what it is. The software will fuse regardless what you have just been scanned. And the minimum point distance is 0.02 for Mini 2. And let's take a look at this, advanced. As you can see, the minimum point distance you can set for advanced is 0.08. It's a bigger number than the minimum of standard. But that doesn't mean that advanced is worse than standard. That's because advanced is a smarter way to fuse your point cloud. For example, you might scan some area, like this area you scan for 1 rotation, but maybe you scan the top area for 2 rotations, which will cause an uneven surface, or let's say the thickness of the point cloud. The top area is thicker than the bottom, so it might end up with like a lot of noise or even overlap. So advanced, it can shave the uneven part to maybe shave the too thicker part thinner or increase the thickness of the thinner part. But this is not always the case. Advanced, if you use that, and it might, not always, it might just shave those important parts and it thinks it's unnecessary. So it's better off to determine which method you want to use. And if you're not clear and if you're not familiar with this method, I would recommend you start with standard first. So in this case, let's choose standard and choose minimum 0.02 for our point cloud. Okay, now let's go. And the software will tell you how many minutes it will estimate to do that. This is a pretty small 3D model, so it will be quick, I suppose. It says 3 minutes, but I think it will be done by right now. Okay. And as you can see, now the point cloud looks thicker than what it is raw, right? And here this is where you can choose which stage you are in now. Now, previously we are under raw, and now we're under fused. And mind this, if you are not satisfied with what you have just done, you can go back to raw and choose another method you want to do it. And you can apply it again. It will ask you, do you want to override? You can click OK if you want to override that. And it applies for fusion and also for meshing. I'll talk about that later, meshing. Okay, now as you can see, after you fused your point cloud, the right side, there is a selection tool bar, it'll appear. You cannot use the selection tool when it's just under raw point cloud stage, okay? So now this is first this is click. Just use this to click, and you remember you can go back. You better choose click when you want to rotate it again. For example, like this, this rectangular. This is as what it means. You can draw a rectangular, include this part in it, and if you want to delete that, you can do it. Look, now if you want to click, it won't allow you because you are now at rectangular selection tool. How to fix that? You can click back this arrow, this mouse arrow, or if you're under the rectangular selection tool, you can press Alt. No, maybe not Alt, Control. Yeah, Control. You can press Control. It will also allow you to rotate it. Okay, and if you do something wrong, don't worry. For example, like this, I accidentally delete this part, and I don't want that. You can choose this Undo button. And also redo if you want to go back one more time. And also polygon allows you to draw a polygon. Whatever the shape you prefer, you can just do that. And remember to connect the end to the starting point. So that'll be a closed loop. And also lasso, it'll allow you to draw a circle. And I'll leave you to discover what's the rest of those selection tools. Okay. So we have deleted that part, but it's not always necessary to use this selection tool to delete any part that you don't want, because we can use this isolation tool. And this tool allows us to detect and determine which part is isolated, like this is not connected to the main body of the 3D model. So that'll be considered as isolation. You can use this to detect, auto detect that. Let's see. Okay, as you can see, not only the two tissue paper is detected as isolation, but also a lot of small noises on the surface of the main 3D model will be detected as isolation too, right? So if now if you want to get rid of it, you can click this, apply, and boom, it'll be all gone. But here, this bar, 15%, what does that mean? So let's go back to the previous step. Now, if we set this bar as 100%, look, this is what's going to happen. Okay, it's not get deleted, but this bar, actually this 100% means, and down to 0.5% means how big this isolation you want it to be determined as isolated. For example, sometimes you are scanning two separate items together, and you don't want this coin to be detected as isolation. So in this case, you can tune down this bar and choose, for example, 5%, so that it will keep this coin but will delete the other smaller item as isolation. So this is what this bar does. Okay, now let's just redo it and go to the next step, overlap. No, I've just explained what can cause overlap, mainly due to that you scan some area more than one time, it might cause overlapping. So then you can use this tool to detect and auto delete all the overlapped point clouds. Okay, boom, click apply. And now this 3D model will be more accurate because you get rid of the thicker part. And this bar, this number, this parameter means what the overlap distance will be detected and determined as overlapping. But this number is very hard for you to manually diagnose because it's very hard for you to see like what part is more than 0.13 millimeters, right? So it's better to use this function only for default. Like if you click this refresh button, it'll go, like if I change this and I don't know what to do, I can just click this and it will take you back to the default number. It's very recommended to use this default number the software auto-generated for you. Okay, now smooth. Smooth is just what it means. It will smooth up the surface, make your 3D model smoother. But this is a function I would like you to take care of because some of the model, like this Medusa here, the shoulder, this area is very smooth, right? So this area is definitely a good place you use this function. But if you're smoothing up the very detail, like the hair, the snaky hair part, look, these are super detailed. If you use smooth function too hard, like if you choose too strong strength on this one, and times means you want it to repeat how many times. So if you do that a lot, it will cause you to lose all of those tiny details on the surface. So be careful and don't use it too much on the super detailed 3D model, okay? So in this case, let's just use 10 and times 10. Let's just do that once. You can repeatedly do all these processes as if you wish. Okay, let's just do it once, looking good. And then simplify. Simplify. Now, if you take a look at here, the points is a lot. It's almost like 6 million? Yeah, that's a lot of points, and the file size will be might be bigger than you expected, especially for those, the 3D model, big 3D model you scan with Morocco or Range 2. And then you can use this function to shrink down the file size and the points and eventually the polygons of this 3D model. And here are two types, uniform and geometric. So uniform, this will simplify your 3D model very evenly. It doesn't matter which part it is, it just divide the 3D model into a lot of cubics and it will simplify, shrink the size of the points like evenly. But geometric means it will only shrink down the areas that does not have a lot of features, like the shoulder, these areas. But it will not do too much shrink down when the areas have a lot of details. So it really depends on which type of 3D model you're scanning. Okay, and the ratio is how much you want this model to get shrink down. So in this case, let's use geometric because I want this to be, only this part to be shrink down. And 40% looks good. Let's apply that. Okay, done. and as you can see, the points now are almost half, right? Okay, now let's go to the next step, meshing. Meshing is to mesh all of the points you have just fused and make them into a real surface. So then your point cloud will be looking like a solid 3D model. And as you can see, remember I told you I haven't scanned all the overall, all the direction of it. There's a lot of holes and even empty spaces at the top and the bottom. And I do that for a reason because I want to talk about this hole filling function. Now, first, quality. This is just what it means. If the bigger this number is, the better quality you can get, but longer processing time and bigger file size will happen the same, okay? So in this case, let's just choose maximum 6. And hole filling auto. If you enable this, it'll automatically fill all the holes regardlessly of the 3D model, of the point cloud that you just scanned. And this is a function I do recommend you use it, and you only use it when you are pretty sure about you only have some small holes in the 3D model. But like in my case, now in this case especially, there is a big plain hole, empty space at the bottom, right? So in this case, I'd recommend you don't use the automatic hole filling function. Instead, you can choose to fill holes manually, and that's not complicated at all. Let me show you. So first, let's mesh it. Okay, done. And now this looks more like it, right? Look at the hair. These areas are pretty cool, pretty detailed, right? And the tear on the face, you can also see it more clearly. Right, so now isolation, you can detect isolation once again, but we have already did in the fusion part pretty good. If you're not sure, you can just choose to detect once again. It won't detect a lot of things. Okay, now fill hole. There are two methods, plane and curved. This is what it means. Plane, it'll fill the hole with a plane surface, and curved will be filled in a curvy surface. So in this case, first let's choose curved and choose detect. Okay, that's a lot of holes. We didn't scan. This wasn't a really good scan, right? There's a lot of holes we didn't scan very well. So now if you want to fill the holes, now it's end up with green. Green means it's unselected. So if you want to select the hole you want to fill, you can click on it. But that's a lot of holes you want to do, right? So you can choose to use the selection tool to include all of the holes you want to fill. And just in case, because we don't want the bottom area be filled with a curved surface, because if we want to print it out, we want this to be stand on the table or surface, right? So we can deselect this by clicking on it again, and we choose apply. Okay, and we can choose plane and choose detect to fill the bottom, so that will be a closed 3D model. Okay, just click that and choose apply. All right, very well. But let's take a look at the final result we got right here. Look, this area, it does not look really like what it is in the 3D model, right? This area here and this area here. And also there are a lot of holes we see on the top of the head, especially the hair part. Look, these are the parts we use the fill hole function, and it lost all the detail because it cannot anticipate what it is in the originally 3D model. So this fill hole function is really not a non-stop solution for your scanning. It's always better to fully scan an object instead of leaving a lot of holes, especially the big holes, to let the software fill for you. You better only fill the hole only for the tiny little holes you created, like you accidentally created, like here and here, it's like at the tip. And that's really the way you should do, okay? Okay. But overall, it is a fine looking 3D model, especially I seen from the back, right? Okay, now smooth and simplify is almost the same with the smooth and simplify in the fusion stage, but it's slightly different because now you are working on the surface and the polygons. Before, you are working on the points, right? If you want to do that, you can choose to smooth and simplify your meshed 3D model once again. And again, if you have a super detailed surface, it's better not to smooth and simplify it for too many times and too strongly. Okay, and texture, we haven't scanned this in the color mode, so it won't allow us to do the texture mapping, but that's easy. If you're doing the color scan, you just simply click and apply for it. There's nothing to talk about. And merging, Travis already did in the previous video. If you want to see how you can merge two different scans into one complete 3D model, you can go to the previous video in the playlist. Okay, now, finally, export. You can export point cloud, meshed model, or the texture model, which we don't have yet in this case. And or export all of them. Let's click mesh model, and you can choose any file location. You can choose to store them, and you can select 3 different formats: PLY, OBJ, and STL, based on what you need. Okay, and you can choose the file location. Just click save to save it.